Hi, welcome to Chapter 5. Let's talk about inferential statistics. Hypothesis testing, scientific method, requires the development of a scientific hypothesis and an inferential statistical test of that hypothesis versus another competing hypothesis. Your hypothesis is a statement of presumed relation between at least two variables in a population. Your population and the parameter. Population is the entire group of people or observations in question, and your parameter is a measure of interest in the population. A sample statistic. Sample, a subgroup of the population of interest. Statistic is a measure of interest in that sample. Here are some statistical symbols. You can see what the mean, standard deviation, and correlation all stands for when you're doing your formulas. Hypotheses. Research hypothesis. What the research actually believes will occur. Your null hypothesis is a statement that there is no relation or association or difference between the variables. An alternative hypothesis is a statement there is a relation, association, or difference between the variables. Statistical significance. Significance or alpha level. The probability value chance of results happening only by random chance allows testing of the probability of the actual occurrence of the result, or conventionally set at 0.05 or 0.01. Your type 1 and type 2 error, making an incorrect conclusion about the results. Type 1 error, equal to the alpha level, concluding there's a relationship when in fact there is not, rejecting the null hypothesis. Or there's a type 2 error, concluding there is no relationship when in fact there is one, failing to reject the null hypothesis. Type 1 and type 2 errors. You can look right there. Alpha level and SPSS. SPSS will compute the alpha level for you. If the probability is less than the present alpha level, 0.05 or 0.01, you conclude there's a significant relationship between the variables. Your variable, you have an independent, which is x, generally nominal in nature, which means number. And then you have your dependent, y, which is a nominal dependent variable measured by frequencies or proportions, and it's continuous, an interval or ratio measured by mean values. Here are some variable classifications. You've got your independent and your dependent. So you have your presumed cause, presumed effect, the antecedent, the consequent, manipulated or measured by research, your outcome, your predictor from, predicted to, predictor, and then criteria. It probably would be really good to go over this in the book again because sometimes people get independent and dependent variables. That's easy to confuse. And so make sure you refer to this chart when you're doing your assignments. The overview of hypothesis testing and inferential statistics. 1, develop a research hypothesis about the relationship between variables. 2, state a null hypothesis reflecting no relationship or difference. And 3, state an alternative hypothesis. This is the opposite of the null hypothesis and is a direct reflection of the research hypothesis in number 1. Gather data and analyze them based on the research questions and the type of variables, and then make a decision based on the probability of the null hypothesis being correct given the data you've collected. So here's selecting a statistical technique. And again, these are in the book, so I encourage you to go over them a little bit more detail. Let's talk about a chi-square. Example, a chi-square aerobics instructor teaching 2 classes wants to... All right, let's talk about a chi-square. Example, aerobic instructor teaching 2 classes wants to see if the proportion of males and females is equal for each class. Your null hypothesis, there is no association between gender and type of class, but an alternative hypothesis would be there's an association, a relationship between gender and type of class. So here's an SPSS, which is a statistical research package. Crosstabs output. So you've got class enrollment, what type of class it is, and then they ran a chi-square test to see the correlation between the type of class and the gender. T-test for 2 independent groups. Example, high school coach is selecting players for varsity team based on serving accuracy. Coach wants to know the difference in serving accuracy between varsity and sub-varsity players. So your null hypothesis, the mean for varsity players is equal to the mean of the sub-varsity players. It means there's no difference between the two. or there's an alternative hypothesis. The mean for varsity players is not equal to the mean of the sub-varsity players. And here's the serving scores. Now let's look at the sample t-test, group statistics and independent sample test. So you've got your what was significant, a two-tailed, and again, you plug all these into your SPSS, and this is going to tell you, this is going to give you what you need to know when you perform that t-test. A dependent t-test for pair groups. Example, the volleyball coach is interested in serving accuracy for the varsity squad at preseason at the end of the season. The coach tests the players at the beginning and the end of the season. Null hypothesis. The mean preseason serving accuracy is equal to the mean postseason serving accuracy. Remember that null hypothesis says there's no difference between the two. But your alternative hypothesis says the mean preseason serving accuracy is not equal to the mean post-serving season accuracy. And then you've got your data format for a paired t-test. You got preseason and postseason right there. And then here's your sample t-test output. And so you can really read the significance. Was there a correlation? Was there a standard deviation? You can read all of those right there. Then you have one-way ANOVAs. Example, strength training with 3 training methodologies: free weights, machines, and elastic bands. Each participant engages in one and only one of the 3 methods of strength training for 8 weeks. Strength is measured with an 1 RM bench press. We want to know which training method is best, and that's why you would run a one-way ANOVA. The null hypothesis, the means for 1 RM bench press for the 3 training groups will be equivalent. An alternative hypothesis means for the 1 RM bench press for the 3 training groups are not equivalent. And let's go back here. Input, here's some input, what you would put for the group, how much they bench pressed, and then here's the results. It sticks out. What was the mean, standard deviation, was there an error, minimum, maximum, was there significance? All of that is right there in that analysis. Then you can run a two-way ANOVA. Examples, minor league baseball players were tested on their fielding coverages. Players were categorized according to the position. Pitchers are position players. And instructional methods, drills, or scrimmages. So a two-way ANOVA, the main effects of the null hypothesis, there's no difference in fielding coverage, and there's no difference in fielding coverage between instructional methods or pitchers and position players. Then similar to our previous test, we have an alternative hypothesis for each main effect, which are, in addition, we have a test of an interaction hypothesis. The interaction hypothesis tests whether or not the instructional effect is constant between the positions played. And here's your data input for the two-way ANOVA. And then here's your SPSS, two-way variable labels and descriptives that came out of that with the method scrimmage drills and then between subject factors. Here's the rest of that two-way ANOVA summary. You can see how significant it was right there according to the source. And then summary. This chapter provides a brief overview of inferential statistics. Many of these assumptions regarding the use of these tests have not been discussed. Significant findings should be evaluated carefully with their practical implications in mind.